Alright, boys and girls here, Mr. Arnold going to take a look at 16.2, taking a look at atomic structure, taking a look at the periodic table of elements and how we can find out the number of protons, electrons, and neutrons. First of all, what we need to be able to look at is an element square. An element square has a couple of things for us to notice. The first one, the top number, which is always a whole number, there's never a decimal, is simply the atomic number. The middle part is what we call the chemical symbol, and that is the one or two letter notation that tells you exactly what element we're talking about. And then the decimal number, the bigger number on the bottom, is called the atomic mass. And so from that information we should be able to derive, get the number of protons, electrons, and neutrons. We'll assume that all atoms are, for this point and purpose, neutral in charge, which means there's no charge. They're balanced out. So the atomic number is always going to be equal to the number of protons. So since the atomic number of sodium, which is Na here, is 11, that means we have 11 protons. That's what identifies the atom as a sodium atom. If it has 10 or if it has 12, it becomes something new. It's not a sodium atom, it's a different type of atom. Neon would be 10 and 12 would be magnesium from there. Since we have 11 positive protons, in order to remain neutral, we have to have the same number of negative electrons. And so, if I have 11 protons, I must also have 11 negative electrons to balance each other out. The last part that we need to know is what is the number of neutrons. Neutrons have no charge. That's nice because we can have more or less. We don't have to worry about actually finding or actually balancing them out. So the number of neutrons is hidden inside the atomic mass. The atomic mass is the number of protons plus the number of neutrons. And again, that is the actual center of the atom, the nucleus. That's where all of the mass of the atom is actually located. Because we can't have part of a neutron, we have to round the atomic mass. We're going to go by our rounding rules. If it is 5 or above, we round up. If it is 4 or below, we round down. So for this sodium, the atomic mass is going to be 23. And that 23 is equal to the number of protons, which we said was 11, plus the number of neutrons. So the question is, how do we solve for this? Well, whatever we do on one side, we got to do the other, right? Since we're adding here, we're going to subtract 11 on this side to cancel that out. And whatever you do on one side, you do on the other side. So 23 minus 11 is 12. We actually have 12 neutrons. And again, there's no charge on that, so it really doesn't matter exactly what's going on. But again, from the square, you should be able to tell me the atomic number, which is the whole number. That atomic number is always equal to the number of protons, which is also equal to the number of electrons. I know it's getting a little bit loud. Lunch is getting ready to come back. The chemical symbol, which is a 1 to 2 letter representation of the element that we are using, and the atomic mass, which is the number of protons plus the number of neutrons. Moving forward here, a couple other things that we need to know. Atomic mass, again, is equal to the number of protons and the number of electrons. Tells us what the atom is. So what are we using? Oxygen, hydrogen, etc. from there. Again, tells us what the element or atom is. And the average atomic mass is simply the number of protons plus the number of neutrons. Notice the term average. Average is taking into account multiple things here. Some atoms can have more or less neutrons inside of their nucleus. Remember, neutrons have no charge, so if they have no charge, they don't affect the overall charge of the atom. It just affects the atomic mass. So the average atomic mass is going to be all of the isotopes combined together. Mr. Arnold, what is an isotope? An isotope is just simply an atom that has different numbers of neutrons. Meaning, if we take a look at it this way, carbon, here's this information for carbon. Carbon has an atomic number 6. Tells me I have 6 protons, 6 neutrons, and an atomic mass of 12, which means I should have 6 neutrons. Sometimes, though, we can have carbon 13. Carbon 13 means I still have 6 protons, I still have 6 electrons, but now, I've picked up an extra neutron. The neutron does not affect the overall atom itself, it just means I have a little bit more mass. I can also have carbon 14. And again, all I'm doing is adjusting the number of neutrons in that actual atom. So for this, carbon 14, I no longer have 6, I actually have 8 neutrons in that atom. So taking a look, these are all what we call isotopes. And again, isotopes, where do these come into play? Isotopes come into play when we are talking about the average atomic mass. That's going to be on the periodic table. That is the big decimal number that you see. The atomic mass of an element is the true number of protons, and I said electrons. That is incorrect. That should be neutrons there. So if we take a look here, atomic mass is the actual number or true number of protons and electrons for that actual atom. Here, sorry about that, that shouldn't be there. So for carbon 13, the atomic mass for carbon 13 is truly 13 because I have 7 plus 6. For carbon 12, the atomic mass is 12 because I got 6 plus 6. But if I was to add up 12, 13, 14, divide that by 3, you would notice that that would actually come out to be a decimal number, and that decimal number would then become my average atomic mass. Alright, sorry about the pause there. Just to kind of recap of where we're at, some things that, again, you need to be familiar with or things that you need to look at. We should be able to look at a chemical or a periodic table square. We better be able to identify the atomic number, the atomic mass, and the chemical symbol. You don't need to memorize those. You just need to know what to look for those kinds of things. From there, you should be able to tell me the number of protons, electrons, and neutrons. And you can find the number of neutrons by simply looking at the atomic mass minus the atomic number. There is a difference between atomic mass and average atomic mass. Atomic mass is for the actual specific element, which is protons and the neutrons. That's average atomic mass is for all of the isotopes. Sorry about that again. Actually, that one I did spell right. Isotopes that are actually combined together. So this is where we would add every isotope available for that element, and then we would divide that, this one here being 12, 13, and 3, divide that, or 14, and divide that by 3 to get that average one. Again, just hopefully this helps clarify. If not, please come see me.